Hello.
Can you hear me now?
Yes.
Oh,
Yes.
I can hear you.
Awesome. Hi, everyone else. Austin and Lauren. We're just gonna wait a few minutes, make sure we get everyone in. Ooh, hello. You guys are so quiet for now. Lauren, you're in a dark room.
There we go. I didn't realize I'm still on my boyfriend's Zoom and I don't know how to fix it. My name is Ray. I'm not Austin.
Oh, got it. Got it. I was like, you don't look like an Austin, but that's okay.
No.
No, that's great. Where are you guys all from?
I'm from Arkansas.
Oh, wow.
I'm from Pennsylvania.
Awesome. Pennsylvania. Everybody else? Anyone from Illinois? That's where I'm from.
Lecter desperately wants to make an appearance. There you go, bud.
Yes, I love it.
Dr. Catable Lecter.
I love it. Anyone else? Where are you guys from? Come on. Susanna? Jen?
Arkansas.
Oh, yeah, I got you already. Sorry.
I lived in Illinois.
Oh, really? Wow. We're in Illinois.
Urbana-Champaign.
Got it. Got it. Yeah, I'm in Chicagoland area, so but I go to Urbana quite frequently. So I'll be actually down there first week of June. So yeah, I work for AHA, so I accredit all the hospitals in the Midwest area. So I travel. So we're finally starting to travel again, which we'll see how long that lasts. But yeah. Everybody else, come on. Oh, I got another person waiting for me to let them in. Everyone's like, we don't want to meet on a Friday, but I just did it last minute. So next time we can always. Oh, Conda, I've been there too. Who's Pixel 4? What's your name? Or is that your name, Pixel 4? I'm going with that's your phone, but. Susanna, you look very organized with your board behind you.
My hubby put the whiteboard paint on the wall for me.
That's awesome.
He did.
Yeah, it's good for your review and stuff. I'm not even that organized for myself, so that's great. You're new to the Zoom thing. Yes, it can be hard to hear. Can you hear me okay? I'm a pretty loud person, so. You may have to turn volume up if you need to, or some other people may need to turn their volume up as well if you're having a hard time hearing. So I know I've had to learn these platforms pretty well with obviously the new social distancing and stuff too. So Zoom is not the favorite choice, but it works for now. And then Teams is okay, but obviously can be a pain in the butt to get people for signing up and figuring out how to make it work. And then Facebook, of course, just threw theirs on recently, so that's why I was like, oh, let's try this. But then it probably would have worked for today, honestly. But I wasn't sure how many people were going to be able to make it. And so out of a group of 10,000 people, I was like, I don't know how this is going to work. So we can always do that in the future if we know how many people are going to really join, if it's going to be less than 50 people. So that might be the easiest way to do it. So we'll see how it kind of goes from there. Oh, Kelly, the Kelly I know? Is that who you're talking about? All right, so we'll go ahead and start for everyone, and then we can always I'll admit people as I see them coming in, hopefully. So today I figured we could start with some math. I think that's been kind of a struggle for some of you guys from what I can see. So please feel free to dive into what you guys really want to work on for sure. I know that I put up something earlier in the week that was kind of an overview of what I gave my group of people from an anesthesia class that we did back when I was teaching recently. And truly it was from them just kind of not getting a lot of math. And so I dove in and did a bunch of math with them. So whatever you guys feel that you kind of had some questions on from that end, we can work on too. Or if there's some other things that you guys feel like you have questions on as well, we can go over as well too. So feel free to just dive in and ask me some of those things, and then I can always go over that, or I can just jump into and go over certain aspects of that stuff too. So I'll leave it to you guys first, and then otherwise I'll take the lead. So. Come on, it's your time. How about acid-based stuff? Did you guys get that pretty well?
I think we ever covered that in school.
Yeah, it's hard. It's a really hard subject to cover. And truly, when I taught it, I taught it as, hey, this is something that truly is an extensive thing. I want you to know the very basic stuff about it. And you guys don't have to know everything about it. And so when you are even in practice and doing it, there's so much more to it. And it's so funny because when you are working with other people, you know, when you're in practice, I never want you guys to think, oh my gosh, we have to learn the secondary component to it or whatnot. Just at least having the basic down of, hey, I can recognize that the pH is acidotic or alkalotic first. And then knowing from there, is my HCO3, which is the bicarbonate, right? So, which I can go over with you guys again so you can get that. Is that abnormal, or is my CO2, which is the respiratory component, is that abnormal? And then gauging from there, do I have a respiratory component issue, or is it a metabolic component issue? So what I'll do is I will go over that quickly with you, because that is something that I think as a technician, whether you guys go through, you know, I'm not sure what specialty you guys are going through, or if you guys are even general practice, if you guys have a patient, it's nice for you guys to be able to look at blood work. I'm sorry. Sorry, I missed.
No, I just got my audio to start working.
Oh, okay. So what I am going to do, so I showed my screen with you. So what I'll do is I will
I'll call you back.
just try to show you quickly just some notes that hopefully I'll be able, okay, I have terrible handwriting, so FYI. But so when we look at our pH, so our pH, oh, this is going to be really fun. Let me get my, all right, I just want to disconnect that. So when we look at our pH, your normal pH, obviously for a patient, is going to be 7.35. Oh goodness, that's not nice. To 7.45, right? For our regular patient. And so that's the first thing that you want to look at when you're looking at any problem. So if you guys had your homework, look at me, I'm already back in school mode. So if you look at all of those problems, that's always going to be the first thing that you look at. And then when we look at our CO2, so that's your carbon dioxide. So when we think of carbon dioxide, you should already be thinking, okay, that comes from our lungs, right? So we can then visualize and say, all right, so that's our respiratory component. And so the nice thing in order, because we have to memorize like so much stuff for your VTNE, our normal for that is easy to memorize because you have this 7.35 to 7.45. It's going to be 35 to 45. All right, and a unit wise, because I'm weird about units, is millimeters of mercury. Okay, and then I talked about HCO3. Okay, that's called bicarb. All right, or bicarbonate. And so that normal range is 22 to 26. All right, and so again, that's millimeters of mercury. All right, my students would always get me every time I forget to put a unit on there because they know that I'm crazy about it. And so what we do is the first step when we look at this is to determine, all right, are we acidotic or alkalotic? So if we're going this way and it is below the 7.35 to 7.45, if it's below that 7.35, then we're acidotic, all right, regardless of anything else. If it is higher than that 7.45, then it's alkalotic, all right? And then the second thing that we do is we can look at the CO2 and then the bicarbonate. So if you had that homework or sheet from before, and say we had the first one that's there, so it would be 7.13. The 7.13 is low, right? So it's below that 7.35. That would be what? So 7.13 is going this direction, right?
Acidotic.
Acidotic, good, right? So we can already determine over here that it's acidotic. All right. So the second part, oh, sorry, I gotta let people in. The late people, they always have to bring me coffee when they're late. That's what my rule, even at 6 at night. And then, so the second part was that the CO2, so we'll go with CO2 first. The CO2 is 49, okay? Sorry, my email's popping up. The CO2 is 49. So the CO2 being 49 is within this range, or is it above the range or below the range? Is it normal?
Above.
I'm sorry, I missed you. What?
Above?
Above, good. So it's abnormal, right? Abnormal, yay. We like abnormal people. I always say that. I'm like, I'm abnormal, so it's fine. All right, so that's abnormal. So now the HCO3, so the bicarbonate, right? So that one is 24. So 24, is that normal?
Yes.
Yeah.
Yeah, so normal. So that one's good. So when the abnormal one is the winner, I say in this case. So meaning that it would be this guy is acidotic, and we pick the abnormal one. So it would be a CO2 is, right, respiratory. So it would be a respiratory acidosis. So we always pick the abnormal one as the answer, okay? Because this is normal in the normal range at 24. Your bicarb is metabolic. This comes from the kidneys. That's why. Oh no, I lost you. Come back to me. Oh, I just lost the whole thing. I'm like technology, like challenged. Okay. So, yeah, we just picked the abnormal one, and then the one that wherever that pH is, you know, which way the pH is going, okay? So say we have your pH is 7.35 to 7.45, correct? And then you have your CO2 normals is 35 to 45. Let's try another one. And then HCO3 is 22 to 26. So what if we have a 7.33, and then I'm just gonna pick random things. A CO2 of, oh, I don't know, 42, and an HCO3 of 16. Oh goodness, what am I doing? All right, so the first thing that we do is what? Look, it came back. What the heck? Let's go away. I don't want you right now. Everyone. Go away. Okay. Okay, so our 7.33 would be going in which direction? This way, right? Yeah, acidotic. Awesome. And then how about this guy? Normal or abnormal?
What was the second number? I don't see the numbers.
Oh, you don't see the numbers? Okay. The number is 42 for the CO2.
Normal.
Normal, good.
Normal.
Awesome. And then the HCO3 is 16. Abnormal, good. So our abnormal, again, is the winner. So this is the one that we pick to be our overall answer. So our HCO3 is considered, well, we call it bicarb. So bicarbonate, which comes from the kidneys, remember. So that is our metabolic or respiratory?
Metabolic.
Metabolic, good. So metabolic. So your answer is metabolic acidosis. Okay. So in all actuality, when you guys, and so essentially when you guys are doing this in practice, the big reason why we need to know this is that your body functions like this every single day and is balancing itself out. So say you have an animal who's coming in, that's a DKA, right? So have you guys learned about DKAs? So diabetic ketoacidosis. So DKA, so it's acidotic, so it may come in being like a 7.22, okay? So it's severely acidotic, and it's going to be a metabolic acidosis, all right? But its carbon dioxide is also going to be super abnormal too, and so it's going to be panting like crazy. And there are so many times where people think that they're in respiratory distress too. And so instead, we have to have this understanding that they're not in respiratory distress. It's the body's way of trying to balance out its pH level. And so it's kind of an interesting concept to things. And so we have to, having that understanding can be really beneficial when you guys start having more and more knowledge within the field. So having that basic concept of it now is really helpful for when you guys get further along in your career. So I know it sounds a little crazy and everything, but just kind of keep that in the back of your head for the future, so that you're like, oh yeah, I kind of remember doing that, and you can see this on your boards or something similar to it. So just kind of keep that in mind. I'm surprised a little bit that you guys didn't do it, but sometimes it can be hard for teachers to even understand some of those concepts as well. Any questions so far? Okay, and we will continue as we go along. This isn't like the first time that you have this concept and then you get it right away. So don't worry. You will always have questions like more often than not. So we'll definitely touch on it again. Okay, so next on the list of things that we talked about before, maybe we can go through some calculations that I thought that you guys probably had questions on. Was let's see, dehydration stuff, those crazy problems I made you do. Anyone?
I think that's a good idea to go over those. That's where I struggle.
Okay, great. Yeah, I saw a lot of questions on those, so I thought that would be good. So like, I think it was like number 11 on that work that I saw a lot of that struggle. So I'll kind of go over the dehydration part. And you guys will definitely see this often too, is that fluid deficit aspect. So when you talk about fluid deficit or dehydration, the formula for that is always going to be that percentage times, or I should start off actually. Let me back myself up. So it's always going to be your kilograms times your percent, okay? And there's going to be sometimes schools that may teach calculation a little bit differently, okay? You will see most books teach it this way, but some teachers may teach it slightly different, all right? So if you see it kilograms times percent as a decimal, so like 0.07 as a 7%, if that makes sense. So if you do it like that, and then you multiply by 1,000, okay, that will get you the mLs, right? Some people will leave it in the form of kilograms, and then do it until they just get it into a liter. Did anyone learn it that way? Or did everyone learn it this way?
I learned it how you were teaching it.
Okay, perfect.
Mhm.
If anyone learned it differently, please let me know. Because this is the biggest, this one is like the one that you see the most. But sometimes I have seen other people come up with different formulas, and then I go, okay, I'll help you learn it that way too. I don't care as long as you get the answer. So when you're doing that as well, so you are getting your amount of fluids this way. You will get the amount of fluid that they have been deemed dehydrated, and you can rehydrate them with whatever in the amount of time that your doctor says they would want to rehydrate them. So as you saw in those problems, some of them said over 18 hours, some said 12 hours. Of course, I made them difficult even in like 20 hours, right? And it couldn't just be 24. So from there, that was the first step, right? From the second step would be figuring out your maintenance fluids, right? So this is dehydration. Okay, so maintenance fluids, how did you guys learn maintenance fluids?
We do 60 for dogs, 40 for cats.
Okay, so yeah, and I've seen there's so many different formulas out there for it depends too, like if you work with an internal medicine doctor, sometimes they do different things, but the main overall consensus, yes, can be 60 for dogs. Some people still do 60 for cats. Some do somewhere between 40 and 60 for cats. So whatever you guys have learned or do, oh goodness, or whatever you guys, you know, typically, you know, do in your practice is totally fine. So 60 mLs per kilogram per day, right, for dogs. And then if you're doing cats, so 40 to 60 mLs per kilogram per day, okay, for cats. Now, remember that in here, if you were going to have to figure out this in a different amount of time, so say we're going to have to do this over, you know, 18 hours for the end of the problem, right? We have to break this part down, like these two down, from that day mark to 18 hours. So you may have to figure out this maintenance down to the hour and then multiply it to the amount of hours.
I think your screen share might be paused.
Really?
At least for me, it's not coming up.
Okay. Thanks for letting
For me
know.
as well.
No.
Me as well too.
Hmm.
The only one.
Yeah,
All
I
right.
can't see what you're writing.
Interesting. All right, let me, it's like your handwriting's so bad that, all right. Is it working now? Oh, wait, let me, amount of hours. Giving. Is it working now?
I'm only showing the pH and CO2. And
Yeah, that's where it's
HCO3.
stuck.
Stuck
Yeah.
on the pH.
Yeah.
What?
Mhm.
You pH, you need to leave. Like, okay. I don't know why the pH thing wants to be here so bad. Interesting. Ugh. Okay. Is it showing it now? No?
Nope.
No.
Okay. I'm back now. Let's see. Let me try to share it again. See, technology is not my friend. I was like, I can do this. I can do this whole whiteboard thing and it'll be great. All right. Is this working? Can you see?
Yeah.
Please.
We can see that
Yeah.
now.
Now
Yes.
it works? Ah, okay, good. All right, amount that we're giving, right? So you might have to break it down to the hours rather than the day, and then multiply it to the amount of hours that you're gonna have to, of the total. So it's like, it's like a double weird process in that problem. So that's why, like, for number 11, I kind of gave you that weird number 2. I said break it down to the day, right? And then in that number 3, I said, oh, for the amount of time for correction, as like that extra hint, like, look at the correction time is 18. So it made you break it down again. Okay, and so here's the ongoing losses. So ongoing losses is the number 3. This is where all of my students hated me the most. And then I get thanked after they take their VTNE every time. Every time. I made them in the beginning of anesthesia class learn what is it called? Conversions. Did you guys learn conversions?
Mm-hmm.
Yes.
Like how many mils are in a cup, how
Mhm.
many
Yeah.
mils are in a teaspoon, like all that. How many pounds are in a gallon of milk? We had to learn that, but I had a really old like large animal teacher. So we just entertained it and we loved him for it. It's 8.6 pounds, by the way. And it weighs the same amount as your head. I don't know if that's really true or if he just told us that. Okay. So I still made them learn it too. I was like, no, you have to know that. So it just it's like telling if you're really paying attention to your teacher. So calculating your losses, so ongoing losses is truly like your owner, you are going to say, hey, how much did so-and-so vomit? They're not going to know, like, oh, 300 mLs. I mean, I might say that, but So they might say like a cup or 3 tablespoons, or, oh my gosh, it was so much blood. That's usually what they say. And it's like 3 little spots of blood. But you guys can rough guess like how much that is. So if it's 2 cups, you guys should be able to know what that is in mils, right? What is that? 2 cups. Let me check real quick. And I'm like pretty lenient on that. Like I would tell my students, you know, if it's 480, you know, mils, because some people are like to the T. Some will even say it's 237 mils in a cup. I'm like, oh my gosh. I would even say, okay, you can like do 240, or you can do, you know, like 250. I don't even care, because, you know, there's 4 cups in a liter. Like, it's all right. So just at least knowing your conversions. Because on the VTNE, they will be like, hey, break this milligram dilly-dally down to a microgram, or what is this 2%, right, solution down to this microgram, or I'm sorry, this microgram per 10 mLs or something ridiculous. And you're like, what? So they're just trying to trip you up. So it's really important that you know that it's 2 grams per 100 mLs, and that your teacher didn't just teach you that you put a 0 behind it to make it 20 milligrams per ml. Right? They didn't teach you that, right? Oh, jeez. Is that how they taught you?
Yeah, that's how they taught me.
Right. Okay. Back to square one. All right. So on a tangent, when you have, did anyone else learn that? Or do you guys know what that means? Okay. So when you have a percentage, so 2%, okay? So 2% of a solution means that in that solution you have a drug, right? Like there's something in there, and then you have water that made up that solution. So in that drug, you have 2 grams of that drug in there, and then 100 mLs of water or whatever that's in there to make up that drug. Okay. So when you simplify all of that down, right? Because we have to simplify it. How many milligrams are in a gram?
1,000.
Good. So 2 times 1,000 is 2,000, right? 2,000 milligrams over 100 mLs, correct? And then we simplify that down. So to simplify, I could just cross out zeros, correct? So I cross out these 2 zeros. Cross you out. Okay, I'll admit you. So when I cross out those 2 zeros, it leaves me with 20 milligrams per mil. See that?
Yeah.
So the big reason why you need to know that, though, is because on the VTNE, they're going to give you 2%, and then they're going to give you an ABCD, and they'll say simplify this. And the answer choices might not be 20 milligrams per mil being the answer. It might be like 200 milligrams per 10 mLs be the answer, right? So you still have to know like what that means, if that makes sense. Or it could be like 20 grams per 1,000 mLs is the answer. So they try to get you to know what the best answer is. So yeah, now granted, when you're in the moment in practice, you're not going to be like, hold on, let me get my notepad out and do all the math. You can put the 0 behind and do it. All right. Oh, I should have go back. Never mind. Let me go back. Oh, you guys probably, because I didn't finish that part. So you guys can still see my screen, right?
Yeah.
All right, so ongoing losses we have here. So what we do here, I went on my tangent. I can't do that anymore. So from there, we do dehydration. All right, so we had our dehydration amount that we would get, okay? And so we have that total that you would have. So the total that you get from that, the total from the amount for the time given for that, we would put here for maintenance. And then the total of ongoing losses, so the ongoing losses you put there, and you add those up together, you get that amount, and then you divide that out to get the mils per hour here. I'm sorry, the mils, and then the mils per hour there. So let's do a problem together and we can solve that. And then you do your drips per minute. So we'll do one together because it's completely an insane board right here. Okay. So I'm just gonna make up something. Let's say we have a 43-pound dog who's 5% dehydrated. And we want to rehydrate in 12 hours. And the ongoing losses is 2 tablespoons. Oh, this would be a capital T, 2 tablespoons. All right, I made it really easy. All right, so first let's change our pounds to kilograms to make life easy. What do we have here?
19.5.
Great, 19.5. Okay, so for our dehydration, what would our formula look like for that?
19.3 times 0.05.
Okay, awesome. And then we multiply that by
1,000.
1,000. Awesome. And then, so what would our total be for here?
975 mils.
Awesome. Great. So that is our number one thing that we are gonna have for that part of the problem. Good. So hey, don't move on me. Now for our maintenance. So this is a dog. We don't want a 43-pound cat. No thanks. So for our cat, or I'm sorry, gosh, our dog, 19.5, I think. Yeah. Kilograms times, and what's our formula for that?
60 mils per kg per day.
60 mils, awesome. So, what do we get?
1170.
1170. All right. So that would be mils per day. Yes. Great. And we made it pretty simple because it's going to be for 12 hours. So how are we going to figure that out for our 12 hours then?
Have it.
Have it. Good. So what do we get for our 12-hour?
585.
585, awesome. So I'm just gonna put it here, 585 mLs per 12 hours. So
Wait, how did you get that?
divide 1170 by 2 because we're doing for 12 hours. Normally though, you would just take 1170 divided by 24 and then multiply by 12.
Okay. That's how I learned it.
Yeah. But we're being big lazy bums.
Okay.
Yeah.
All right.
Big lazy bums on Friday night. Awesome. So that is number 2. All right. So ongoing losses. All right. So 2 tablespoons. What is it? How many mils are in a tablespoon?
15.
15.
You guys are good. Good job.
That's one thing I do know.
Good job, teachers. How many teaspoons are in a tablespoon?
3.
Wow, good. All right, so this would be 30 mLs, yeah? Or 2?
Yes.
Yeah, okay, good. So,
Which is 1 ounce.
good job. That's awesome. You know how long it took it to like tell my students they had to know that? They didn't think they will like believe my threats. I was like, no, you have to know this. I'm gonna test you on all of it. All right, so the 4th part is to add all 3 of those guys together, right? So 975, add the 585, and then this tiny 30 mLs, which is probably not going to do much of anything even if we didn't add it, but that's okay.
1590.
1590 mLs. Awesome. So we need to give this over how long again?
12
12
hours.
hours.
12 hours. So we're going to divide by 12 hours, and we get
132.5.
132.5 mLs per hour. Awesome. So now we get to do our drips per second if you work at a practice who doesn't have an IV fluid pump. So 132.5 mLs, okay? So this is the part where, again, it varies on how you were taught, on how to do this next part, whether you're like a linear type of person or whatever. I am make things as simple as possible so that life is so much easier for math. So for the hour part, how did you guys learn it?
I didn't learn this.
You didn't learn it? Wow. Okay.
Put
So
1 hour underneath the 132.5.
okay.
Put 60 minutes and then
Okay. So here you have, okay, you have like your hour, right? So how many minutes are in an hour?
60.
60 minutes are in an hour, yeah. And then how many seconds are in 1 minute?
60.
60 seconds, yeah. All
It'll
right.
be 30, right?
So if you multiply those together, what do you get?
3,600.
3,600 seconds are in 1 hour, right? So what you're trying to get on the bottom right here is seconds in the end, right? That's your end goal, is to get drips per second, correct? So what I taught my students was make this as easy as possible. So I said, if you can remember the 3600, then let's do that. Because it was starting to confuse a lot of people, even when I was in school, to be like, okay, putting the hour and then the minute there, and then, you know, getting finally down to the second. Just remember 3600 seconds is in an hour, and maybe it'll come up in trivia someday. Like, that'd be awesome. So then they were like breezing through this stuff. So 3600 seconds. And then the next part is super easy. What drip set do we use for these guys? Do you guys know drip sets?
Would it be like drops for a second?
So how many, yeah, so do we have macro sets and micro sets? So it's usually based on how big an animal is. So like
15.
if you, yeah, they have like the 15 drops per mil are your macros, okay? And your micro sets are the 60s, yeah. But, and people are like, well, I don't understand. Why are there so many? Because they're micro drops. They're little tiny things, right? But they're in mils. So you have these itty bitty tiny drops in 1 mil and these huge drops in 1 mil, okay? So what we typically do is macro goes for any animal that's over 7 kilograms. Okay. Micro we do for the under 7 kilograms. All right. So for this guy, it's a 43-pound dog. So we would put him on a what? The macro, yeah.
Macro.
Good. So it's 15 drops. So 15 drops. So we want drops in the top anyway, per ml.
Wait,
And
so
so
15 is the macro?
yes.
Okay.
Yeah. And so we want to have the drops in the top and seconds in the bottom, right? Look, we did it. And then these are the linear people that like math to look pretty. So we cross out the mils, look. So we did it right. So now we just have to do the math. So we just multiply our 132.5 times the 15 divided by 3600. And it's going to come up with probably something weird.
Like 0.55.
0.55.
Great. 0.55 whatever, right? So that would be drops per second.
Per second.
Okay, now.
Can I round that to 0.6 or do I leave it at 0.55?
Yeah, you can round that one to 0.6, but if you really want, so first, well, I should say this. You can't give a 0.6 drop.
Oh, yeah.
So we're going to have to multiply that by something to get to a whole number.
Okay.
So I would say that you can either multiply by 10 and then round it to the next number from there. That's fine. Or if you are adamant at getting the exact number, I have some students that do that and I give them extra kudos for it. But I'm okay with you like multiplying by 10 and then just, you know, going to 6 drops per 10 seconds or something.
Okay.
Fine. So yeah, from here, if you went times 10, then you would get technically 5.5 drops per 10 seconds. And then just saying 6 drops per 10 seconds. When you guys start getting good at it, you can start playing with your calculator and being like, okay, well, maybe if I multiply by 9, what do I get instead of 10? Or what if I multiply by 12 or something like that? Can I get a whole number at some point? If I want to be exact. Some people say, screw it, I'll just get it close. So it's up to you guys. Does that make more sense to you guys?
Yes, thank you.
Okay. You're like, I don't want to kill myself after all that.
That's
Yes. Yes, yes, yes. Did anyone say something? No?
I just said that's a lot of numbers.
It is a lot of numbers. Don't you love it? You're like, no, I don't. Okay. So where are we? Let's go to, actually I should just save it. No, go back. No, I don't want to, we don't want to play like that. Okay, let me just move it. Okay, so how do you guys feel about like C1 times V1 and all that?
I need help with that.
Awesome.
I don't get it.
I don't get
Awesome.
it. I hate it.
I love them. They're so much fun.
Maybe if I was good at it.
Everyone loves them. Okay, so they can be challenging for sure to understand. So if you have, let's say, a 50% dextrose, right? And then you have 50% dextrose and you have 750 mLs of LRS, and you need, let's see, and you need to make a oh gosh, a 5% solution. Oh goodness, I can't write. Stop moving. 5% solution. How many mLs would you add? Right. So, oh, I just gave you the one from before. Let's change this to like 950. So how would you put this together essentially? So the way that I think of it is I picture it in my brain, right? So this would be, okay, I have a bag of fluids, right? That's hanging. Okay, here's my bag. Okay, and it's 950 mLs on this side. All right, and they're asking me that I have to make up a 5% solution. All right, this is my stock that I'm going to have, my little tiny bottle of 5%. But I don't know how much I need out of here, correct? Right. So now I need to fill in my blanks. Okay, so I have 950 mLs and 5%. You don't even need like these little, you don't need your mLs or percent. But I don't know how much mLs here, and then my 5%. Okay, so the whole C1V1 is just like a formula, but truly all you have to do then is your math and then solve for X of being how many mLs. But it kind of is like that visual picture for you. But you just have to figure out, okay, well, how many mLs of my stock am I going to have to end up putting into here eventually?
But now, wait a minute, isn't your stock 50%?
Oh, I'm sorry. I lied to you. Yes, you're right. I just forgot my 0. Okay, but I'm going to need to know how many mLs from my stock I'm going to need in order to put into this bag.
Don't you have to change percentage from MIGs to mil?
Nope. Nope, not at all. You do not even need, technically you don't need to add any of these in here. It doesn't matter. None of our units matter in this problem at all.
Okay.
Yeah, it's actually fairly easy.
8.1.
So if you guys want to do the math in here, let's go ahead and do it. So 950 times 5, what is that?
4750.
I'm sorry,
750.
1,750?
4,000.
Oh, 4,750.
700.
Okay. And then this would be 50x, right?
Right.
Okay, so then what we do next?
Divide it.
Divide by
Divide by 50.
Divide by 50, good. To
Be
just get,
95.
and then what do we have?
95.
95.
95, good. So x equals 95. So that means because we knew we were gonna need mLs, right? We need 95 mLs of our 50% solution to put into here. Now, remember, this is for like when you're in practice.
place it, right?
Exactly. So we have to take out first 95 out of your bag because we can only keep 950 in there total. So you take out 95 and then you put in your 95 because otherwise you have way more than 950. Does that make sense?
It's actually a lot easier than I've been trying the whole time. So
You need pictures.
yeah, I do.
Yeah, I am like very visual. So here, let's try another. I'll make it like weird. Let's do you have 437 mLs. You need 7.5% solution. Oh gosh. And you have a 70% stock. How many mLs do you add? You can tell that I've written my whole life in the animal hospital field. Okay, so now what do we do? Do you want to draw a picture? Why not? Now you guys are going to do this when you take, well, you can't because you guys, took my VTNE on a Scantron, but because I'm old, but you guys will be on the computer. So you'll be like, can I have a cheat sheet on the desk so I can draw pictures? So where do we put our 400 and
Piece of paper.
you do? Oh, okay, good. You can just draw pictures the whole time. I need to doodle, sorry. Okay, so where do we put our 437 ml? On the big box, little box? Goes
Big.
over here. 437 mLs, that's our little solution man. You need to make 7.5%. Where's that go? Over here, over here.
Big.
Big, good. All right, how about the 70% stock?
Little.
Little. I'll remember the 0 for now. And then how many mLs do you have? That is our unknown, yeah? Awesome. So now we just have to fill in our numbers and then do the math. So 70, and then we got our x because that's our unknown. And then 437, I'll try to write nicely, and 7.5, okay? So now we just have to do our math. I'm gonna forget about all of the units and try not to OCD myself on it. So on this side, we just have 70x, which is great. And then what is our math on this side? It's probably some crazy disaster.
32,770. No.
33.
3,277.
Oh, you broke up. Sorry.
3277.
3277. Oh, 3277.
77.
0.5.
0.5. Okay,
0.5.
thanks.
Yep.
Oh, wait, 3277.25.
0.5.
0.5.
No.
That's right. We're
That's
too
right. Okay. I'm like, I should have my calculator, but I suck. Okay, so awesome. And then we need to do what next?
Divide.
By 70.
Divide by 70. Awesome. So we divide that by 70. And what do we get?
46.82.
36.82. Great. And you guys are going to draw that up, right? So I usually say to students, round to what you can draw. Is that how you guys did it in school?
Yeah.
Okay. So what could you draw up?
46.8.
46.8. Okay. So 46.8 mLs. Awesome. That looks lovely. You guys got that? That seem better? You seem like you can go and teach someone that? I feel like once you teach it to a person, you got it. You got one more, you said? Did someone say that? One more? No? I feel like I'm hearing things. Maybe I'm losing my mind. My students would all say that. They'd be like, yeah, definitely. Okay. Any questions? Anyone want any other math things to go over?
Totally confused between crystalloid and colloid.
Oh, good. Crystalloid. So crystalloids are the fluids that you would get when you are really dehydrated, right? Say you've been really sick, vomiting, that type of stuff, just to rehydrate you. Colloids are the fluids that plug up the holes in your vessels. So like your vessels are not just tubes that transfer, fluids throughout your body. They actually are semi-permeable. So there are tiny holes through that so that way things can transport throughout your body. And so colloids are protein that kind of plug up those holes so that fluids can get through to where they need to go. So like, let's see, crystalloid would be LRS, normal R, plasmolites. I think of crystalloid as like crystals being tiny, right? So those are the tiny fluids. You drink your crystalloids essentially, right? Every day, like your water. Colloids you wouldn't want to drink. That would be terrible to try. Colloid is blood, a blood product, right? So whole blood, plasma, packed red blood cells. Hetastarch is a synthetic colloid. It's a man-made colloid. And then vetastarch is a synthetic. So we had a hetastarch is the human version, because think of it as heta being H, human. And then we have vetastarch, which is the veterinary one. I've been around actually long enough for when it first came out. And everyone's like crazed for it, of course. What is the dose for hetastarch? Does anyone know? No. So for head of starch, we can't go over certain dosaging in head of starch. So for head of starch, see, you asked a great question. For head of starch, we can't go over 20 mLs per kg per day, okay? Because there has been studies done that it can increase coagulopathy in people and animals. I'm not sure what people's dosing are because I don't do people at all. But so it can have coagulopathy issues. There has been known some issues with renal problems too, but the biggest one is coagulopathy. So that's a big reason why we can't go higher. So that's why VetaStarch came out. It came out back in 2009, I want to say. So VetaStarch has a dose too that we can't go over. All right. So typically it is 50 mils per kg per day. We try to stay in that range. There are some textbooks that will have like a range between 50 and some higher dosage, but most of them say 50, okay? So it's nicer to be able to have VetaStarch. However, VetaStarch, of course, is a little bit more expensive. But those are the synthetic ones. There is another synthetic out there too called oxyglobin. Has anyone ever heard of oxyglobin? Anyone? Oh, you have.
It used to, but I've heard of it.
Yes, so I'm old enough to know that is too. So if anyone's planning on working in Europe someday, like the UK and all of that, I mean, why not? They have it over there. We used to have it over here and it went off the market for a while and stuff, but it is synthetic bovine hemoglobin. And so it's really good for if you have an animal who can't get a blood product right away and is needing oxygen support, and you can at least give hemoglobin that way. So it can obviously maneuver oxygen to the tissues for the meantime as a band-aid until you get blood to it or whatnot. So it has a great shelf life and you don't have to refrigerate it and all of that jazz, but it's pretty cool. So those are your synthetic colloids. Natural colloids are your blood products, cryoprecipitate, that kind of stuff, and then your crystalloids being like your salines and your LRS plasma light, all of that jazz. That help?
Yeah, thank you.
Yeah. Yeah, no problem. Just remember, you can drink your crystalloids, but you can't drink colloids. Or you shouldn't, only vampires. Vampires. Any other questions? Trying to think. We have oxygen flow rates and stuff. If you haven't checked out already, and I'm not only plugging the place that I work, but I truly do think that this is great to take a peek at. Anyone like anesthesia? You guys are like, I'm so afraid of anesthesia. You should really check out the AHA new anesthesia guidelines. Because some of the stuff that we went over for the math stuff is actually in the new anesthesia guidelines. So it talks about like the O2 flow rates. It also talks about, I'm trying to think, the O2 flow rates, all of the rebreathing, like the breathing bags, all of that stuff. It goes through pain management too, so that's kind of cool. That has pictures of how to do all of these cool blocks and everything, which has nothing to do with math, but it's really cool. It also goes over monitoring parameters too. So it might be a really good review for you guys. And yeah, I think it's really cool. Oh, my sharing like died on you guys. And then trying to think. Any other questions that you have? I think that I'm going to do another, obviously, review session for you. One of the things that I think is probably going to take some time is going to be the ECG stuff, because ECGs take a long time to handle. They're like a whole thing within itself. And then one thing will be some monitoring, and then one thing as well as pharmacology.
That'd be good too.
Yes. Pharmacology is a few within itself. Anesthesia pharmacology is one thing, and then especially getting a handle on those guys is one thing within itself, and then some other pharmacology. So, but you guys let me know too, like what you all specifically really need help in, because I mean, this is all for you. So, I mean, I always need help in stuff too, but yeah, you guys keep me posted. You guys are always welcome to message me and let me know what you guys specifically want, and you guide me on what you'd really like to learn or get refreshened up with. When are you guys planning on testing? I know it's been a hot mess, but.
Well, I've rescheduled my third time. Now it's the end of June. So.
Oh, okay. So it's coming.
Yeah.
But
hopefully I
yeah.
passed it. I've failed twice now, so we'll see.
Okay. I mean, now you know what to expect. It's okay, honestly. Like, I studied for my critical care boards and failed twice and retook the third time and stuff. So they're hard. So, I mean, they don't make it easy on you.
Yeah, well, I think one of the things that, I mean, before I started this program, I've been in my clinic now for 12 years, but I mean, I'm 45 now. I went through college back in the 90s originally. So,
yeah.
You know, a lot of this stuff, the math stuff, like CRIs is still, I can't wrap my head around.
Yeah.
But I've never been a good test taker anyway.
Yeah.
I did this online program, but I could only do it like kind of one class at a time. So it took me like 9 years to get through the program. So some of the early stuff, you know, at this point now, it's been like 10 years ago I took the classes.
Yeah.
You know, so it's.
Yeah, that's interesting too, to go through a program over that amount of time. And I think too, like even our board exam has probably changed quite a bit from when I took it, like 12, 13 years ago. I can't imagine, I don't think that we did CRIs or anything quite like what is expected now. So we didn't even have pictures on our exam, and I know there's pictures on it now. So I mean, not to say that I disagree. I would have loved to have pictures on my exam, to be honest, you know. And like I said, we were expected to go downstate, so we all sat in a huge room together with like, I don't even know, hundreds of people on a Scantron. So it was crazy anxiety, but yeah, I don't know. I can't imagine taking it on a computer though. So it's weird to me.
And I'm more hands-on anyway. I mean, I've been basically working as a tech student for 10 years now. So the hands-on stuff, I'm good.
Right.
Fine, but yeah, the computer, you know, trying to remember things, sitting at a computer, getting stressed out, it just blows me out.
Yeah.
So.
Yeah, and that's why a lot of the questions that I give you guys and stuff for those tests, and when I taught too, a lot of those questions are set up as VTNE questions, because half of the battle is truly learning how to read a test rather than knowing the material. Because you guys know the material for the most part, you know? It's just a matter of, oh my gosh, I misread it, or, oh, I didn't read it that way, you know? So, yeah.
I'm the worst at that.
Yeah.
And I change my answers all the time.
Yeah. So you go through it super fast, or yeah, you second guess yourself, or yeah, it's
Yeah, I'm
just
constantly changing from the right answer to the wrong answer.
yeah.
At least 3, 4, or 5 times every practice test I take. Yeah.
Right. Yeah, so when I put up those keys that are on there, whether we're online here or whatnot, feel free to just send questions out afterwards and be like, I don't understand this, can you explain this answer? And I'll definitely go on there and try to explain it as best I can as a write out type of thing, or, message me or something, because I am almost always on my computer somehow. So I can help you guys as much as I can, even before I can get back on to you right away. Because unfortunately I'm not teaching anymore, but I do miss this. I do want to help you guys as much as I can. So because I do see the struggle that technicians are having passing the VTNE. It's been going on for a really long time, and I want to help you guys as much as I can. So yeah. But I don't want to keep you too late tonight. So I appreciate you guys jumping on with me. Are there certain days of the week that work better for you guys to do this kind of stuff? Friday's
Personally,
probably
aren't good for me because I work emergency. So
yeah, I know weeknights are hard for sure. And my goal is to try to continue to like record these things so that you guys can at least refer back to them, especially, I mean, you guys, my handwriting, as you saw, is terrible. But at least you can refer back to them. I know Friday nights might not be the best for everyone every time. If it's Thursday night, that kind of thing. I mean, it's kind
Recording
of,
them's great.
yeah,
'Cause,
good.
I mean, like the 7 o'clock, my wife's over. So like tonight she's working. So I was putting my son to bed at 7. So,
Perfect.
so at least I can go back and see what you guys did early on.
Good. Yeah, so I can message me if you guys want and let me know what works really good for you guys, like time. I would think time wise that's probably the best, is kind of this later time for you guys. And then if there are certain days, whether it's in the middle of the week is better than Fridays, that's fine too. I mean, I just work. I don't do anything, especially right now, whatever. So yeah, just let me know, but I'm here for you for anything that you need. If you're, it's coming up soon, taking your test, let me know, because I'm here to cheer you on for sure. So yeah, but yeah, keep plugging away. I'll keep throwing things out there for you. But good luck. Keep it going and stay safe for sure. All right.
Thank you.
Thank you, thank you, thank you, thank
All
you.
right. Take care. Have a good weekend.
You
You
too.
too.
All right. Take care. Bye.
Bye.
bye.